guys. So the other day what we worked with was vertex-edge graphs, right? We started analyzing what they actually look like. Again, it's a graph with vertices and edges, a bunch of paths, right? What we're gonna do today is we're gonna analyze something that sounds extremely complicated, but it's actually very simple. It's called vertex-edge graph algorithms, right? And it's a word that I don't know if you guys have heard, algorithms. And all an algorithm is, guys, it's just a type of formula that we use as a representation for other things. So in this way, we're going to end up writing an algorithm, a formula that's representative of vertex-edge graphs. So like we did the other day, right? We had a few vertex-edge graphs, right? And again, it's just a bunch of vertices and a bunch of edges, right? A bunch of paths. So we had this the other day, and again, we can keep it simple, nothing too complicated, right? So we had something like this, right? And again, we practice with knowing what it is, what it represents, what's on there, right? So we have a bunch of vertices and we have a bunch of edges, right? So we can call it A, we can call this C, we can call this E, we can call this one M, and we can call this one F, right? So looking at this vertex-edge graph, we have the vertices that we have, which are A, C, E, M, and F, right? Let's make that M look better. We have M right there, right? And F. And then if we're analyzing what the edges are, what the paths are, we know it's AC, we know it's EC, we know it's EF, we know it's EN, we know it's MF, right? And then if you even wanted to go further, you can start looking at the degrees of each vertex, right? And again, it's just practice from the other day. So if we wanted to know the degree of A, we know the degree of A is just 1. And we know it's 1 because it just goes to C, right? If we wanted to look at the degree of C, we would see that it's 2. And the reason that it's 2, again, C goes to A, C goes to E. So since it has those two paths, it would be 2, right? If we look at E, we have 1, we have 2, and we have 3 because E goes to C, E goes to F, E goes to M, right? There's our 3. And then M has 1, 2 going to E and F. And then F would also be 2 because it goes to E and it goes to M, right? So again, those are the degrees of the vertex, of the vertices. And then if we wanted to know what the degree of the entire graph is, the degree of the entire graph would be 3 because it's the highest degree out of everything. So that would be the degree of the graph. Those are all the degrees of the vertices, right? And again, that was just practice, just to make sure that you guys remember that idea from the other day, right? Again, it's nothing too complicated, but it's just good to always go over it. What we're going to be doing today is writing algorithms. We want to represent this in a way that's always easy to look at, right? And again, it may sound complicated, but it's not. I promise that. So if we're looking for a representation of this, okay, we know that this represents a graph, right? And that graph is just a combination of vertices and edges. So if we wanted to start writing that, we could, right? We know that we have a graph, and that graph is equal to vertices and edges, right? And that's all this begins to already represent. That's the start already of our algorithm. It's a representation saying that we're talking about a graph, right? That graph is equal to vertices and edges, right? So G stands for graph, right? V stands for vertices, and E stands for edges. That's all it is so far, just a very, very basic representation. And whenever we're dealing with vertex-edge graphs, that's our representation. We can start off with that. Graph equals vertices and edges. And then, whenever we have that, again, we know that a graph is made up of 2 things. It's made up of vertices, and it's made up of edges, right? It's made up of all the vertices and then all of the edges. So we have to represent that as well, right? So if we wanted to start, first thing we're going to start with in the graph is the vertices, right? And if we're talking about the vertices, again, it's a lot easier than you think. All V is going to represent, again, V represents all the vertices that we have, right? So what are the vertices that we have? We have A, right? We have C, we have E, we have M, and we have F. And that would be it for vertices, because all that is, again, order doesn't matter. But now, forget about the graph. If I'm looking at this, I know I'm talking about a graph that's made up of vertices and edges, right? We know that all of the vertices are A, C, E, M, and F. Exactly what we're talking about here, right? Knowing that these vertices are that. And then the last thing that's left for us to talk about is we have the vertices. Now we need to talk about the edges, right? And the edges, again, sometimes could be the more complicated one, but it's still very easy, guys, because all we're going to represent with edges now is all of the edges that we have. So what are all the edges? What are all the paths? So the first one that we have is this one right here, right? And I'll put them up there so we can start working on it. First one we have there is AC, right? So it would be AC. And again, that's just to represent each edge, right? So right there, AC would be 1. So we put AC as 1. And the reason we put the comma there between 2 is just to show, since there's no path, you're showing it's going from A to C, or C to A. It's just a joining of those two. So that was our first one. Our next one we can write, this one right here, right? So this one right here, we can call that CE. So we call it CE, right? CE. That's another one that we have. Let me just make that look more like a parenthesis as opposed to a C. We have that one as well, right? And now we just keep going through the list, right? We have another edge right there, right? So that one we can call it EM, right? So we call it EM, right? We have this other one here, which we can call that MF, right? We have MF. And then we have one more. We have this last one right there. And we can call that one EF. And since we don't have any more, we're done with that. Literally, that's all it is, guys. And when we look at it, again, it looks complicated, but all it is we start off with this, right? The graph is equal to vertices and edges for this, because that's all we have. Our vertices, which is the easiest thing to write too, it's just literally listing what are all the vertices, A, C, E, M, and F. And then the edges, it's just going one by one to show what each edge is. So we have AC, AC, we have CE, CE, we have EM, EM, MF right there, and then EF right there. That's all it is, guys. This is the algorithm. This is the representation that we have for this. Because sometimes it doesn't look like it, but this makes this unnecessary, because once you have that, you know what this is. And so next week, we're going to be using this to actually create our own vertex edge graphs. But for now, what I want you guys to actually start doing is just getting in the habit of writing this. And we're going to do another one with that, because I do want you to be comfortable looking at it, and I do want you to be comfortable actually creating them as well. But again, creating is what we're going to get to work with in the next class. For now, though, I need you to have a good understanding of this, so that'll be easy for you, you know? Again, let's come up with another one, where we have that, where we have that, we have that, we have this. There you go. So we have that. We have a vertex edge graph, right? Get a bunch of vertices, a bunch of edges, and then let's just label them. We can call this one H, we can call this one E, we can call this one D, we can call this one M, we can call this one L, and we can call this last one here, we can call that one X, right? So we have H, E, D, L, M, and X, right? And so, again, if we wanted to represent this, first thing we can do to represent this, again, since it's a vertex edge graph, we can start off. Always start off with this to let you know. So we have a graph that's going to equal vertices and edges, right? Again, it's the way we always start with our algorithm. It's a representation, shows that our graph is equal to vertices and edges, right? And the first thing, the easiest thing to do, start by labeling all the vertices, right? So all of our vertices that we have, let's look at them. We have H, right? We have D, and again, the order doesn't matter, guys. We have E, we have L, we have M, and we have X, right? So there are 6 vertices, right? We have H, D, E, M, L, and X. We have those 6 vertices. That's our representation for those vertices. Because now we have our graph, we have the vertices. Now we just got to figure out what our edges are. And again, the edges are not difficult at all, guys. It's just going through them one by one. So we can start off with this one right here, right? So the first one we can call is HE, or you can call it EH, doesn't matter. So we have HE, right? We have then the next one, which we can call ED, right? So we have ED right there. And then the next one, we can call the next one right here. So we can call that one DL. Right? The next one that we have would be right there. So we can call this one LM. Again, LM, ML, doesn't matter, guys. And then we're just missing one more. We're missing this last one right here called LX. And again, it's a good way to check too, just because we know we have 1, 2, 3, 4, 5. We have 1, 2, 3, 4, 5. So we have all our edges. We have all 6 of our vertices. 1, 2, 3, 4, 5, 6. We're done. There's our algorithm. That's what an algorithm is, guys. It represents our graph, and it shows us everything. It shows us our vertices, shows us our edges, right? And again, it's once you have this picture becomes completely, it becomes, I don't want to say pointless, but you don't need it because all the information that you have is there. And what I mean by all the information, let's take a look at it. Let's say I wanted to figure out what's the degree. Let's say I wanted to figure out what's the degree of each vertex, right? Without a picture. So let's say I wanted to first start off with H. What's the degree of H? So now if I want to figure out what the degree of H is, I can look at it. So I see H is here, so that's 1. And then H doesn't show up anywhere else. So the degree of H would be just 1, right? So now the next one, if I wanted to figure out the degree of D, right? There's no D there. There's 1 D there, so that's 1. There's another D there, so that's 2. So that's our degree of D. If you wanted to now figure out the degree of E, right? E is there, so that's 1. E is there, so that's 2. No E there, no E there, no E there. So our degree of E would be 2, right? If we have L, right? No L, no L, 1 L, 2 L's, 3 L's, right? So L shows up here, L shows up here, L shows up here. So that degree would be 3. And it's just getting in that habit, guys, where you have M then, right? No M, no M, no M, 1 M, no M. So that would be 1. And then our last one, X, would be none, 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 1, there. And this is what I'm trying to get you to understand. So if we wanted to figure out the degrees of each vertex, we have them, right? Just by looking at that. If we wanted to know what our vertices are, they're all right there, right? We know that this is a graph. And then if we wanted to figure out what the degree of the whole graph would be, the degree of the whole graph would be 3, because it's our highest degree. And this is what I'm trying to get you guys to understand is once you have this, you don't need anything else, guys, because it's all right there. This gives you all the information that you guys need. Again, hope this helped. Next class, we're going to be actually creating our own graphs, giving this information. But again, any questions you have, let me know.